Okay, let's try round two, Mr. Smith.
Yes, sir.
I'm trying to understand. Let me explain something about interrupt service routines and stacks really quick. When the code is going through the loop, okay, and it's at this while waiting for button to be pressed, or anywhere, let's just say it happens to be down here. It's trying to print playing to the screen, okay? If the user presses the button, this interrupt service routine will immediately be called. So it'll pause whatever it's doing. It'll have to remember where it was because it has to come back here. The idea is that it will go, do whatever the interrupt service routine says, and then come back and continue, pick up where it's left off. It's kind of like if you're trying to, I don't know, clean your house, okay? And you get a phone call. That interrupts, you answer. Once you hang up, you can tell I'm old. Okay, once you hang up, there, new motions for phones. Then you go back to what you were doing, right? You pick up where you left off. Okay, so that's the idea of this interrupt. Not so much, I'm gonna, I'm working throughout my day. I'm gonna go vacuum my rug. Then I'm gonna go change the oil in the car. That's not an interrupt. That's a task that you're taking on. You see the difference? An interrupt is just a real quick interruption to what's going on. Then I'm going to come back to what I was doing.
Right.
Okay. So what all would you put inside the interrupt service routine? I mean, because you can't. We've realized we can't call loop. That doesn't make sense. You could call another section of code.
I think what I'm getting hung up on is that we're not quite to the point of the actual action in the game.
Okay.
We're still, I guess.
So you're trying to get to the game. You're saying, look, we need to get to the game somehow. So
See, I was thinking about being in the game, testing the reaction speed, not getting into.
I see. Okay. So one thing that is confusing about this particular problem is that the button is used both for starting the game and playing the game. Okay. So maybe you're looking down the road saying, well, what's this button? How's this interrupt service routine going to work with the game?
Right.
Okay, when we're playing it. Okay, that's a good question. Let me go back to what we were doing, and let's change this back to button equal, what was it, 1 or 0? I think it was 0, because we wanted to get out of the loop. But so far you can see how, since I'm constrained to use an interrupt service routine, this will allow me to basically pause the program waiting for the button to be pressed, right? Okay, I think I can answer your question by getting down to that portion of the game. Okay, so wait for user to press the switch. Well, that's basically what we're doing. And look what happens. This becomes a comment. It describes what's going on. We're just waiting for the user to press the switch. You know what? Let me try changing the screen resolution. I know it's far too small on the camera. I want everyone to be able to see what we're doing here.
That's better.
Is that a little better? Okay. All right, so now that the button has been pressed, now we need to print playing to the screen. So why don't we just reuse this section of code? It should work. And put it right there. Now, by the way, why don't I just go ahead and solve this thing all the way through where it works. And we'll play the game and you'll see how it works, okay? I don't know if I'll turn on a motor or not, but we'll worry about that in a minute. Well, I may as well if I have the time. But then what I want you to do is try to solve it yourself. You'll see my code and how I did it. You try solving it from scratch as well, okay, without just looking at my code. All right, generate a random amount of time between 0 and 5. Okay, so I need a random function. And I've got to say time equal, and time won't work because it's a special name, so let's call it ran on time. Okay, so this will be, I think the function is random if I remember right. Yep, random is the function. And this will become my comment. It needs to be between 0 and 5 seconds. Okay, so let's see. let's see, I need to look up random because I don't remember the syntax. We know random. Okay, max min, okay. So 0 to 5, if I'm going to use a timer to pause for that amount of time, to delay essentially, then I'm going to go from 1,000 to 5,000. Let me show you why. It's because I'm going to use delay. To delay by that random time. Does that make sense? Okay, so after the time has elapsed, so let's make that a comment. Here we'll say turn on the motor between full and half speed. So I need to turn on a motor, so I'll use analog write. And I need to turn on the motor, so I need a motor pin, whatever that is. Maybe it's an enable pin for the motor on an H bridge. And I need to turn it on with an amount that is between, well, if it's halfway, then that'd be 128 to 255. Does that make sense? So what I'm going to do here is use another random to generate a number between 128 and 255. I don't care what speed it actually turns out to be, but this should work. I'm just analog writing on the motor pin the pulse width modulated signal that's going to be a number between 128 and 255. Does that make sense so far? Okay, so that should do what I wanted. Note the time when the motor was turned on. Okay, so let's say motor on time equals millis. Okay, that'll note the time that the motor was turned on. Wait until the user presses a button. Okay, no problem. I can do this again. There's actually a bug in the code already. And I'll show you what that bug is. What is button equal to by the time I get here? It's whatever it was, right? Button was set to 0 by the interrupt service routine. The purpose of that was to get me out of this while loop, but right now button is still 0. So if I get down to this point, button will still be 0 and I'll just exit the while loop. I will be waiting, right? So what I need to do immediately after the while loop is set button to 1 again. There's another bug in the program. I made button a variable that is supposed to be dealt with in the main loop and an interrupt service routine, so it needs to be volatile. Otherwise I may get unexpected behavior. Okay, so that should take care of those two bugs. So now we're waiting for the user to press the switch. Let's see, I don't need that. Wait until user presses button. Okay, that's fine. So let's say score equals the difference between the time we began, which is motor time on, motor on time, and now, millis. Okay. There we go. Take the difference between start time and now time, print the current score, so I guess I could call it current score, and do a print like this, and then enter a comment. But instead of typing that to the screen, I want to type the value of the variable. And it might be nice to give the user some idea of what I'm telling them by saying your score is and instead of doing a print line, I'd like the score and the your score is to be on the same line. So now your score is, and then it'll print current score, and then print a carriage return. And I'll say serial.print. But the high score is, and then we'll serial print the high score. Now there's a problem here because it's possible that current score will be high score, right? So to make this make sense, let's do this. Let's say if current score is greater than or equal to high score, then we want to do one thing, right? We want to congratulate the user and tell them they've earned the high score, not bother printing out the high score. On the other hand, what I'd like to do is, tell them, well, you could have done better else. So that, copy, actually cut, and paste. A bunch of tab, there we go. But in the if up here, I want to say congratulations, you've earned the high score. Exclamation mark, a happy face, I don't know, something makes them happy. Well, let's see if this works. Serial print, your score is, print current score. Okay, and then if current score is greater than high score, I think we should also reset the high score, shouldn't we? So we should say high score equals current score. Now, I've got a problem in my logic. Our score is basically an amount of time, and the lower the time, the better. So I need to say less than or equal than, less than or equal to high score. All right, let's think through the logic and see if this makes sense. So serial print, your score is, print the score. If the current score is less than high score, then high score is equal to current score. Congratulations, you've earned the, instead of high, let's say best score. For some reason, S-C-O-R-E does not look like the right spelling for score to me. I think my brain's just messing up. Else, serial print, but the best score. Maybe I should say best time. Yes. Okay, so now if current score is not less than high score, then we say but the best time is and print high score. Now, do you think this code is going to work the first time? I don't. It never does. My code never works right the first time. There's already a problem. That problem is that I haven't declared all my variables. If I were to try to compile this, it wouldn't work. First of all, I don't have a current score or a high score declared. And that's what we're trying to do up here. So let's just say int current score. Let's set it to something very high. If it's an int, what's the maximum number it can be set to? 32,767. Why? Because it's a 16-bit and I didn't declare it as an unsigned. If I make it unsigned, in other words, I don't have any interest in negative numbers, now I can set it to 65535. Okay. I need to do something similar for the high score. current score, it really is not all that important that I declare it as 65535. But high score is. If I set high score to 0, nobody will be able to beat the high score, right? Because that's 0 time. Nobody's going to beat that. All right, what else? I don't need this stuff. I don't need a period. I don't need cycles. However, I will need an output pin for the motor. Remember, the motor has, where is it, analog rack motor pin. And I'll assume that's on, you know what, I'm going to set that on pin 13 so it just turns on the LED, okay? It'll turn on the LED either full on or partially on, but for the sake of our program here, that should be adequate. We're running out of time and I want to get through with this. The interrupt service routine I haven't completed because I've got to do a serial or a attach interrupt. And I don't remember syntax. Let's try capital I. If that doesn't work, I'll give up and look on the Arduino site. Yep, there it is. It should be attached to the input pin. And I don't remember syntax. I'm going to have to look it up anyway. I know I need 3 things. Okay, quick example of how to do it. Oh, digital pin to interrupt, that's right. This is the recommended method. So let's just copy it. And I'll paste it. Digital pin to interrupt is input pin. The ISR, I called it ISR, it's just capital ISR. Well, I got lucky there. How about button press? Let's do that. And I guess I could save myself some time by copying this as the interrupt service routine name. Mode, when do I want it triggered? I want it triggered when the button is pressed. Okay? If I trigger it every time the button changes, that's not going to be very good. So I think I want it triggered on high, but I just realized this may not work. Let's see, duo zero, allow high, that's not what I want. Excuse me. Well, I'll tell you what we can do. What I'm interested in is a rising edge. I want it when it goes from low to high. So rising should work fine. And it has to be capitalized. There we go. Now, do I think that's everything? That's all I see right now, but I bet I've missed something. Let's see, button is ran on time. I don't have that. I'll need to declare it. Random on time is a number between 0 and 5,000, so an unsigned int should do just fine. I don't like having extra spaces in my variable declarations. Ran on time. 0 is fine. I don't really have to set it to anything if I don't want to. Let's just let the compiler find any more mistakes. Yeah, output pin. So output pin, I thought no, I did not define it. It's because I've got 2 names for it. I've got it as motor pin and output pin. Let's change it to motor pin. Another check of syntax. Okay, expected something before delay. Yeah, I forgot a semicolon. There we go. Check it. Motor on time was not declared. Okay, motor on time. Let's see. Yeah, that is something different. Okay. Check it. What else have we missed? What else have I missed? Nothing. Do you think it's gonna work now just because it compiles?
No.
No, of course not. I don't think it'll work just because it compiles either. Let's find out. Alright, let's go up in Arduino and actually download the code. Make sure we've got it on the right port. Looks like that should work. Okay, so upload it. If it works, I'm going to be shocked. I think I told you guys I did finally get a program to work the first time I wrote it. I need a wire to act as a switch. All I'm going to do is connect the wire to positive voltage and then just be able to tap it. May need a pull down resistor. Let's see. Actually, I may need a pull up. I forgot that. That digital input pin may need. I forgot to add. Yeah, I've already found a bug. Let's see. Oh, I never did. Yeah, I did declare it. Here we go. Pin motor. I didn't change the pin mode for the input pin. That's a bug. Okay, so input pin. Okay. And let's say input underscore pull up. That way I don't have to put a pull up resistor on it. Try that. All right, now if it's pulled up, then all I would have to do is ground out the pin in order to trigger it as a switch. So now let's look at, it says playing. Let's reset it. Okay, so it's immediately going into playing. Why is it going into playing? Let's see, the level's high. Button is equal to 1. Before it did not, and until I did this, it did not go into playing mode. Let me comment this out. Which means I won't have a button, but that's okay. I'm just trying to debug. Ready to test your response time? Sure. And it shouldn't work because I haven't declared that as an input. So if this is a, let's see, input pull, that means that it's high. Oh, okay, I know what's happening. As soon as I do this, no, the service routine is not active yet. I haven't attached it. So it shouldn't set it to 0. This will be a little dirty, but let's just try it. I'm going to set button to 1 as the first thing I do in the loop. Let's see if that fixes the problem. Because I wonder if the button is being set to 0 somehow by the interrupt service routine, since I have an interrupt or a input pull-up. There. Ready to test your response time. So that should be pin 2. Notice I don't have any debouncing, so this may not work very well at all. Let's see, 1, 2, 3, there we go. Playing. So let's see. The LED came on. Your score is 0. Congratulations, you've earned the best score. Well, that's because I somehow earned 0. Well, that's not what I wanted. Also, I don't want this to happen. I want a space after congratulations, you've earned the best score. So I should have done a serial print line. Okay, and also it looks like I'm going back into playing far too quickly. So how about if we have a delay after the printing? Let's just delay for, I don't know, 2 seconds. That gives me some time to remove the pin, and any bouncing should be done by the end of the delay. I hope I recorded. Yeah, I did hit record. Good. Ready to test your response time? Yes. Okay, so 0, 1. Go playing the game. The LED is not on. The LED just came on. I hit the button. Okay, so the structure of the code seems to be working. However, I've just noticed that I've got a bug. The LED is staying on. I need to turn it off. right? After playing the game, the motor or the LED or whatever I use should turn off. So let's see. Analog wrote it on, waited till the user. Yeah, so as soon as the user presses the button, I should analog write to 0. So instead of that should turn it off. Okay, let's see. Now, I still, for some reason, am getting a very high score. I don't know why. Ready to test your response time? Yes. There we go. So we're playing the game. The LED is so now it's a matter of debugging. Playing the game. There we go. So there's my time. The best time is 0. That's because I earned a score of 0 somehow. I'm not sure how I'm earning a score of 0, unless perhaps the bouncing is causing it. Because when I try to connect the wire to the pin to ground it out, there's going to be bouncing. There's going to be make and break, just like with a switch. You guys have any questions or comments at this point? Got a bug in here somewhere. But I think in general you can see how to solve the problem. It's not, hopefully not too terribly difficult of a problem. I have to make a problem that, in fact I've already made it, but I have to make a problem that is solvable in the time you have. If you got to this point, how much score would you get? Most of it. I don't know where the bug is, but I will look at your code. I'll find the bugs, see how serious I think they are. What features have we included so far? Well, there's a logical structure to the code. It's something that could work. It's not something where I'm trying to play the game in the interrupt service routine. Okay. I've got all the elements are here for accomplishing all the steps. I'll have to find my bug, but I don't want to waste video time. I don't want to waste your time searching for it. So what I'll suggest, if there are no more comments or questions, I'll pause the video. I'll search for my bug, and when I find it, I'll tell you. Go ahead. Yeah.
Where's the pulse width modulation in this?
Right here.
I only see
Analog, right? Because that, remember, we performed the pulse width modulation lab where I had you write your own code to implement pulse width modulation. Then I said, okay, now do it the real way. Use analog write, which does pulse width modulation for you. Look up the analog write command, and I think you'll see what I'm saying. In fact, here, I'll do it for you. Analog write writes an analog value of pulse width modulated wave to a pin. Can be used to light an LED at varying brightness or drive motors at various speeds. After calling it, the pin will generate a steady square wave of a specified duty cycle until the next call to analog write or a call to digital read or digital write on the same pin. Frequency of the PWM signal on most pins is about 490 Hertz. On the Uno and similar boards, pin 5 and 6 have a frequency of about 980 Hertz. So the pulse width modulation is just, it's just there. It's just in the command. It just does it for you.
I was getting confused with something else.
Oh, I see. Okay. Anything else? Okay. I'm going to pause the video and find my bug, and then I'll start the video up again.